Okay, we're going to be looking at the percent ionic character in bonds in compound materials. So if you go back and watch the video on covalent bonding and ionic bonding, you'll see that at the end of the covalent bonding video, I mentioned that we can have both covalent and ionic bonding in a material. So this is actually very common, and it's pretty rare to have a purely ionic or purely covalent compound material, or material that's not made out of the same element. So the degree of each bonding type depends on a few things, and these are all kind of under the umbrella of periodic position. So this is how I briefly sketch the periodic table, the shape of it. If we remember what it means to be electronegative, we remember that a difference in electronegative is a difference in the distance. So an element here and an element here are going to have very large differences in electronegativity, as well as an element here and an element here are also going to have very big differences. So we can look at the difference in electronegativity as a separation in both height, well, I guess it would be, height going diagonally, so this way, or distance horizontally. And so that's going to cause a greater difference in electronegativity. And what this then means is that's going to be a more ionic compound. And vice versa for covalent. If you have two atoms that are really close to each other, you're probably going to have a more covalent bond. So if we have let's just say we have two different elements. We're just going to name them A and B. You can apply this to many different examples. A is going to be more electronegative. And B is going to be less. And so the electronegativity of each of these, we're going to denote as XA and XB. And again, that's the electronegativity of each atom, where A is more electronegative. So if you're given an example that has two elements in it, you would determine which one is more electronegative and assign that to be atom A. So the equation that we then use is our percent ionic character, and this is equal to 1 minus the exponential negative 0.25 XA minus XB. Again, that's the electronegativities squared. And then to get that as a percent, of course, we multiply that all by 100. So you can go ahead and just plug in your values for XA and XB again. And this is how you are able to find the percent ionic character. And if you do this with a couple different examples on your own, you'll start to see that it's pretty rare to have fully ionic or fully covalent if you have, of course, a compound material. And we can see that if we didn't have a compound material, we can see exactly why it wouldn't occur. XA and XB would be the same, and basically everything would just cancel out.